Hello everybody, welcome back to Elementary Astronomy. I'm John Armstrong, your professor, and today we're going to be talking a little bit about the laws of motion. Your whole chapter and module this week is about how we figured out how things move in the universe and the laws of motion that come from Kepler and Newton and how gravity works and all that kind of stuff. And what we really wanted to talk about today is how we figured all that stuff out. What was it about our observations of the sky that led us to understanding how gravity works and how objects move. So I thought I'd take a moment today and talk a little bit about the motion of the planets, because it was the motion of the planets which really cued us into what was going on. And you can take a pretty good picture of this by just looking at some of the brightest planets in the night sky. So what we're looking at here is the morning sky on August 14th, so this will be a couple weeks ago, and I'm looking to the east and I'm watching Venus as it begins to rise. And as I go forward in time a little bit, you'll see that Venus rises before the sun does, and there's the sun. So the sun is coming up after Venus in the night sky in the east. So Venus is relatively close to the sun, and we're all aware that the planets orbit the sun, but how can we see that happening? Well, one of the ways we can see that happening is by watching the planet Venus. There are a couple of interesting things about Venus. Let's go back and zoom in a little bit. The first thing is that Venus shows phases. So if I zoom in on Venus, you're going to see that just like the moon, we only see part of Venus lit at any one time. So this is Venus on August 14th. It's at about maximum elongation. In other words, it's as far from the sun as it ever gets in the night sky, and it's about half lit. So if we think about, from our perspective, it looks half lit. So if we think about what that looks like, that means that we have the sun is here. Let's say I'm the Earth, here's the sun. Venus has to be off to the side because I'm only seeing half of it lit. So that tells us something about the position of Venus relative to the sun and relative to us. Now, if Venus was orbiting the sun, then as it passes in between me and the sun, I should see a new phase, just like I see with the moon. In other words, the lit half will be away from me, and I won't be able to see any of it. And if I wait until it's on the other side of the sun, then I should be able to see a full Venus, at least until it's obscured by the sun, and that would tell me that it was orbiting the sun. So let's see if that's actually what happens. We know from observations that Venus's orbital period is about 200 and some days. So I'm going to go back to early April and see where Venus is at that time. So this is April 14th. So let me go ahead and search on Venus again. And then I will see if I can see what time I see Venus. There's Venus right there. And if I look at where Venus is relative to the sun, we'll see that it's now, if I'm looking to the west, the sun is setting and Venus is still up when the sun is setting. And if I zoom in on Venus, you're going to see that the other half of it looks lit. And that's because Venus is now on the other side of the sun. So we can tell that that Venus has, in the course of just a few months, has moved from one side of the sun to the other. And we can kind of see what happens to the phase of Venus as we go through the months. So if I go to the month of May and try to find Venus again, let's see if I can find Venus again. Whoops. Seem to have, there's Venus right there. And now Venus, this is during the daytime still, so I'm going to have to move in the month of May, move a little bit later to see it. In the month of May, I can see that less of Venus is lit. In other words, it's moving into what we call the new phase. And if I go to the month of June, so I go to the month of June, and we're going to have to back up a little bit because now we can't see Venus. It's on the other side of the sun a month later, and still it is just barely lit. So during the month of May and June, it actually passed between us and the sun. And if I go back to where we are now, I will now see it rising in the morning. There's Venus right there, there's the sun. And if we go to July, we'll see that it's more lit. If I go to June, it's even, or August, it's even more lit. If I go to September, October, November, December. Now what happened to it there is now it's close to the sun. Let's see where the sun is here. At some point right around December, it's going to get so close to the sun that we won't be able to see it. So here in January, you can barely see Venus rising just before the sun, and then in February and March, it's now very close to the sun, and now it's on the other side. So when I zoom in on this again, you're going to see that it's full Venus. I'm seeing it fully lit. By the way, with a small telescope, you can see these phases of Venus. This was something Galileo noticed when he first started looking at the night sky with a telescope. So what that tells us then is that if you've got the sun right here, from our perspective, Venus is going around the sun like this. Okay. Now, that gives us a good explanation for why the Earth why it looks like the sun changes its position throughout the seasons, is because the Earth is going around the sun as well. So if I look at, I can come in here and I can turn off the atmosphere, and you can see the stars behind the sun, and those are particular constellations where the sun happens to be in the night sky. And if I go 6 months later focusing on the sun, you'll notice that the sun moves, the sun moves with respect to the stars. So here's Pollux right here, and watch what happens if I go a month later. Now the sun has moved with respect to that star. So in other words, as the Earth goes around the sun, the line of sight between the distant background stars is changing. So we now know that that Venus orbits the sun. You can see the same thing with Mercury. We know that Earth orbits the sun, and you can even see it with Mars. And Mars has a particular feature to its orbit that I want to demonstrate right now, where it looks like it goes backwards against the stars. So it moves forward with respect to the background stars because it's moving along in its orbit, and then for a period of time it looks like it's moving backwards, and then it moves forwards again. That motion is called retrograde motion, and that's because the Earth is moving faster in its orbit than Mars is, so we lap it, right? So if you imagine Mars going around like this, Earth is going around even faster, and we lap it occasionally, and that makes it appear to change its direction with respect to the background stars. So let's see if we can observe that happen with respect to the background stars. So I'm just going to move in day this time, and watch. You can see here, if I zoom in, you're going to see that Mars is moving with respect to the background stars. So we can see this happen with Mars when it's lapped by the Earth, because it appears to move backwards with respect to the background stars. So here I am focusing on Mars, and I want you to watch the motion of Mars as I advance the day with respect to the background stars. So you'll see Mars is moving in one direction with respect to the background stars. And this is if I were to go out every night and observe it at the same time of night. And then at some point it begins to halt and move backwards, and you see it makes a little loop. And in a minute it's going to halt again and go back the other direction with respect to the background stars. Pretty cool, huh? That's called retrograde motion, and it's happening because we're passing Mars, and so with respect to the background stars, it looks like Mars is moving in the opposite direction for a little while. And that's happening because Earth is orbiting the sun, Mars is orbiting the sun, but Earth is orbiting the sun faster, so it laps it every once in a while, giving us this retrograde motion. So all of these observations of Venus and of Mars, the phases of Venus, the locations of these planets, the retrograde motion of Mars, tells us that all of the planets orbiting the sun, and it also tells us that the closer you are to the sun, the faster you go. And these were all clues that led to the discovery of the laws of motion, first through Kepler and then through Newton. Kepler was the one who worked out the rules behind how orbits work, and what Newton did was he connected the motion of the planets to motion of things on Earth. In fact, what Newton realized was that something like the moon, which does orbit the Earth with a speed fast enough that the curve of its orbit is such that it never intersects the surface of the Earth. If I were to throw a baseball, I don't throw it fast enough for that to happen. The arc of the baseball curves down and hits the Earth. But if I could throw a baseball fast enough, it would orbit the Earth. And in fact, that's what's happening with the moon, is that it's orbiting the Earth because it's moving fast enough in its orbit that it just never hits the Earth. So it was these motions of the planets that allowed us to work out this stuff. Now in this module, you're going to be looking at Kepler's laws, how those led to Newton's laws, and how that led to the law of gravity. So I hope you enjoy, and we will see you next time.